In this video, I'm going to be showing you how to complete the square. This is a method for solving quadratic equations. It also gives us the quadratic formula, which I'll demonstrate at the end of the video. So let's just kind of get into it here, and I'm just going to show you the process. So I have ax squared plus bx plus c. This is a general quadratic. And so what I'm going to do is I'm going to divide both sides of this equation by a first. So this gives me this a and this a will cancel, so I'll have x squared, and then I'll have plus b over ax plus c over a. And then if I divide, remember that a is not 0, so if I divide 0 by a, that just gives me 0, because 0 divided by any number is just 0. So next, I'm going to add this kind of weird term here. I'm going to add and subtract it to maintain the equality. So I'll just go ahead and do that here. So I'll have x squared plus b over ax plus this b over 2a squared. And then I have plus c over a. And then I'm going to subtract b squared over b over 2a squared, sorry. And this will still equal 0 because I added and subtracted. That's the same as adding and subtracting 1. Well, that just gives me 0, so I really did nothing. And so next, I'm going to notice something here. So we're going to take a little tangent here, and we're going to compute this. So consider x plus b over 2a all squared. So let's FOIL this. So I'll have x squared plus b over 2a times x plus b over 2a times x plus b over 2a squared. So this tells me that this is x squared plus 2 times b over 2a x plus b over 2a squared. This 2 will cancel with this 2, and I'm left with x squared plus b over a times x plus b over 2a all squared. So I want you to notice that this here, it's not really showing up, but this here is the same as this here. So this tells us that we can rewrite this as this. So rewriting that, we'll say that this is x plus b over 2a squared, and then I have plus c over a minus b over 2a squared equals 0. And notice that this is just a number. We'll show you that in a computation example. And this is a perfect square. So that's why we say completing the square, because we're completing a perfect square. Okay, so let's solve an equation here by completing the square. So what I'm going to do here is I want to, in this case, a is 1, so I don't need to divide anything by anything. But I want to add this factor of b over 2a squared, which in this case, so b over 2a squared, when a is 1, is just equal to b over 2 squared, or 1/2 of b squared. So let's go ahead and do that here. So I'll have x squared plus 3x, and then plus b over 2, so b is 3, so I'll have 3 over 2 squared minus 12, and then minus 3 over 2 squared, and that will be equal to 0. Okay, so I notice that this here is my perfect square, and my perfect square has the form x plus b over 2a squared. So my perfect square here will be x plus 3 over 2 all squared, and then I have minus 12 minus 3 over 2 squared, and that equals 0. So adding this to both sides, I'll have that x plus 3/2 squared is equal to 12 plus 3 over 2 squared. I can take the square root of both sides, so I'll go ahead and do that, and that gives me this. And finally, I can subtract 3/2. Oh, remember that when I take the square root, I get plus or minus. And next I can subtract 3/2 from both sides to get that x is equal to, it's going to be -3/2 plus or minus the square root of 12 plus 3/2 squared. And I can solve this, excuse me, I can solve this for, if I were to simplify this, I would get the answers, the values that satisfy this quadratic equation up here. Okay. So next, I'm going to be deriving the quadratic formula using completing the square. So I'll just go ahead and fast forward through this process. It's just mainly to demonstrate that it's possible. So here we go. Okay, and finally, adding these because they have a common denominator, I get the quadratic formula. -b plus or minus the square root of b squared minus 4ac all over 2a. And this represents the general solution to a quadratic equation. We call it the quadratic formula. And with that, I am done talking about completing the square.